Let's design a parking lot. I'm sure you're pretty familiar with what a parking lot is, but let's go over the background. Usually there are some available spots where a car can park. This is a pretty simplistic view, but in general, vehicles can be of different sizes. Let's say these are just normal sedan cars, but we could also have other vehicles like motorcycles or trucks, semi-trucks, pickup trucks, limos, vehicles of different sizes. Maybe we could have designated spots for those different types of vehicles, or maybe those vehicles will have to take up multiple spots. Parking spots themselves can be numbered 1, 2, 3 to uniquely identify a parking spot. Larger parking lots, aka parking garages, have multiple floors of parking lots. In many cases, parking can be free or it can be charged, and it can be charged in different ways. Maybe for the number of hours somebody is there, maybe they prepay, or maybe they pay based on how long they were there, and then after they leave, they scan a ticket and then are paid for the number of hours that they were in that spot. So there's a lot of nuance to this. So what kinds of clarifying questions could you ask your interviewer given a pretty ambiguous statement like this? We could ask, how many floors are there going to be in this parking lot? Just a single floor, multiple floors, a variable number of floors? What kinds of vehicles will be parked? Just cars or trucks? Will their sizes differ? How will we account for that in our parking lot? Will we have designated spots for those different vehicles or not? Will we have a payment/ticketing system? And how will that work? Can a driver choose a spot that they want to park in, or does the payment system automatically assign them a spot and then they have to park there? How much functionality will the driver even be responsible for beyond just getting a ticket and then going to a spot? Like, do we maybe not even have to implement a driver class, or does the vehicle belong to a driver? Like, how is it going to work? Well, let's say for our requirements, we are going to have multiple floors. A single floor could have a variable number of parking spots. We are going to have multiple vehicle types, but let's say they are going to be limited to regular cars, limos, and semi-trucks. Let's say we are just going to have standard parking spots, but the difference is going to be that a car is going to take up 1 parking spot, a limo is going to take up 2 parking spots, maybe they're parked like this, who knows, and a semi-truck is going to take up 3 parking spots. It's also important that a semi-truck takes up 3 consecutive parking spots. It can't just take up, this, and that. You can't split up a semi-truck usually. And we will have a payment system, which will give the driver a ticket, but will charge them after they leave the parking lot for the number of hours that they occupied a spot. And the way the payment system is going to assign them a spot is by assigning the next available parking spot in the lowest floor possible. Let's say that the parking spots are going to be numbered 1, 2, 3, 4, up until whatever spot we have, and it's going to start assigning them from starting at 1. This is where the first car would be. This is where the second car would be. The limo would go here. And for simplicity, let's assume that all of the spots are in a single row instead of like this, because then we'd have to have additional logic, because a semi-truck would not be able to park here. It would have to go in these 3 spots, but we don't want to have to worry too much about that. Now, if we run out of capacity altogether in all of the floors, then the payment system should not assign a spot and basically just reject the driver and not do anything in that case and not take any payment. So let's start with the high-level design before we get into the code. Let's say we have a vehicle class, because we know we're going to have multiple types of vehicles. I think it makes sense to use inheritance in this case. And we will have a car, a limo, and a semi-truck which inherit from this. Now, the base functionality of a vehicle is going to be that it will occupy a certain number of spots. Let's call that its size. And that's pretty much it. Vehicles don't really have too much functionality. Each of these will inherit from it, but they will initialize their sizes differently. This will be 1, this will be 2, and this will be 3. And this gives us flexibility to add additional vehicles. So it's a pretty straightforward implementation. We will also have drivers, because a driver will not only have a vehicle, it could be any of these types, but a driver will also have to make the payment. For simplicity though, we won't like implement them having a wallet or anything like that. The way we'll do this is by having a charge method where the payment system will charge the driver, assuming the driver gives the payment system their information to like uniquely identify the driver. Then after the driver leaves the parking lot, the payment system will charge them whatever amount that they owe, and then that charge will just exist on the driver. Let's say we have a member variable called like the amount due or something like that, the payment due, and then this charge method just increments that. So we do have like the state of our system working correctly. I think it's kind of superficial for us to say, okay, well now the driver has a wallet, and then we go too deep into that. That's not really what I'm going for, but it's worth clarifying with your interviewer if you want to go super in depth into the payment system and all of that. Now for the actual way we're going to store these vehicles, we're going to have parking floors, of course. How is this parking floor going to work? Well, we need to be able to represent these spots, the available spots. And since we don't have special spots, we can just implement that with an array. So the spots array is going to represent which spots are available and which ones are filled. We could use an enum for this, but since it's just two values, whether a spot is filled or not, we can use booleans or even integers like 0 and 1 for occupied versus unoccupied. And we will have a few methods to like park a vehicle. So given that vehicle, we'll need to be able to get the size of the vehicle, which we'll have to implement on the actual vehicle class. Now it's possible that this parked vehicle will return false if we're not able to park the vehicle. But if we are able to, then we'll have to return true to give some kind of signal, because we're going to have multiple parking floors. But before we get into that, let's also remember that if we're able to park vehicles, we should also be able to free/remove a vehicle to free up the available spots from our array. Now, a single parking floor is just going to be a single part of our parking garage. We could initialize this with an arbitrary number of parking floors, just like the parking floor itself can have an arbitrary number of spots. And this will do a similar thing as our parking floor. Will be able to park/remove vehicles. But the thing is, when we try to park a vehicle, we're going to first try to park it in the first floor of our parking garage. If it doesn't work, then we're going to try the second floor, and then we're going to try the third floor, and then we're going to keep doing that until we find a spot for that vehicle. Worst case, we can't find a spot, in which case this park method would ultimately return false. And we'll pretty much do the same thing for removing vehicles as well. But to actually remove a vehicle, I forgot to mention this, we'll have to know which spots is that vehicle going to occupy, and that information will be stored in a parking floor. Since we know a vehicle could take up multiple parking spots, let's represent the parking spots it's taking up with a range. So a truck or a limo would take up 2 parking spots. So let's say it starts at position 1 and ends at position 2. A single car just takes up 1 parking spot, so it would maybe go from 1 to 1, and a truck would go from 1 to 3 because it takes up 3 parking spots. And then finally, we are going to have our parking system, which is going to be made up of a parking garage, just a single parking garage, because every system will correspond to a single parking garage. It's not necessarily going to have multiple. And the parking system will support the exact same operations. All we're doing is parking vehicles and removing vehicles, but the difference is going to be how these are handled. When we park a vehicle, we're actually going to be given a driver, because think about it, a parking system doesn't necessarily need to know about the vehicle. The driver will be the one providing that information, so the system will interface with the driver, and from the driver, we know a driver has a vehicle, and then the system will be able to get the information that way. And it's important that we pass in the driver, which is the main container for a vehicle, because the parking system is not going to charge the vehicle, it's going to charge the driver. So that's another important thing. And the way it's going to charge the driver is every time we have someone park a vehicle, we're going to keep track of what time did they park. We'll have a hash map maybe for every driver, map it to the hour that they parked at. And then finally, when they remove their vehicle, then we'll get the current time. And then using that, we'll be able to calculate the number of hours that the driver was parked. And then we'll be able to charge them. Also, our parking system should be able to have a variable hourly rate that they are going to charge drivers. For simplicity, let's say that whether a driver has a car that's just taking up one parking spot or maybe a truck that's taking up three, the hourly rate is not going to change. Let's just assume that for simplicity. But if we didn't want to, we could do it pretty easily just by multiplying the number of spots by the hourly rate and then charging them for the time that they were parked in. So that's it at a high level, but now let's actually get into the code, which is what I prefer to do. So let's start with the vehicle. We know that's kind of our main smallest unit that we're working with. And like I said, it's just going to have a spot size. It's the main container. And we're also going to have a driver, which is going to be composed of a vehicle. Let's say a driver also has like an ID to uniquely identify them. And we'll keep track of the payment that they have due, and the ticketing system will be responsible for charging them. Now, we will also have a few vehicles that inherit from the vehicle class. We'll have a car, which we'll just call the super constructor, with a size of 1, limo with a size of 2, semi-truck with a size of 3. We will also have a parking floor, which will be initialized with a spot count, which will represent with zeros, an array of zeros. This will tell us that a spot is empty. We'll also have a vehicle map because, like I said, for every vehicle, we want to be able to know instantly which spots is it taking up. We'll be able to park a vehicle, which will basically be like a sliding window algorithm in this case. It'll have 2 pointers. We'll be iterating through these spots array until we find enough spots for the size of the vehicle, enough empty consecutive spots for the size of the vehicle to fit inside. If we do, then we will populate those spots with a 1 to indicate they're filled now and say in our vehicle map, this vehicle is taking up this range of spots. Then we'll return true. If we can't find a spot for it though, we'll have to return false. Removing a vehicle is a bit more simple. We already know which spots that vehicle is taking up, so we're going to zero them out and delete the vehicle from our vehicle map. And actually, I believe this should be a +1 because it's non-inclusive in Python. We will also, of course, have a parking garage, which will have multiple floors. So the constructor will be given the number of floors that we want and how many spots are going to be in each floor. And then the parking garage will be the one that's responsible for creating those parking floors. So we'll have an array of parking floors with that given size. Now, you could argue that maybe we should pass the parking floors in as a parameter because this does not give us a ton of flexibility, because what if we don't want every floor to have the same number of spots? Maybe we could pass in an array of how many spots we want for each floor, or we could just pass in the parking floors in the constructor. I think either of those would be fine. This way is definitely a bit rigid, but maybe this is fine with your interviewer. It's worth clarifying, I think. Parking a vehicle and removing a vehicle is pretty simple because we have our wrapper. This is essentially a wrapper around a parking floor. To park a vehicle, we would try every floor until we find a successful one and then return true. If not, we return false, similar to removing a vehicle. But it's possible, I guess, that removing a vehicle doesn't even exist in the first place. If it does exist and we're able to remove it, we return true. If we couldn't find it, we would return false. Now, finally, we get into our parking system, which is going to take a couple parameters. The parking garage is going to directly be passed into it, and the hourly rate. We're going to also initialize a time parked hash map, mapping every driver ID to the time that they parked at. We'll say the hour that they parked at because that's how we're charging this. So when we park a vehicle, we get the current time and the hour of the current time, and then we park that vehicle. If we were successful, then we add the hour that they're parked at to our time parked hash map. But if we weren't, then we wouldn't have done this, and we return if we were successful or not. When removing a vehicle, we first check to make sure that that driver was parked in the first place. If they weren't, we just return false. But if they were parked, we get the current hour now, calculate the number of hours they were parked in, and if it's a decimal, we round up and then charge the driver accordingly. And then also, since we're removing them, we delete them from our hash map, then remove the vehicle vehicle and then return whatever the result of that was. You could say, the way I'm doing this charging, what if they were staying for more than 24 hours? Because I'm getting the hour during a single day. Let's just assume for simplicity, though, that a driver won't be parked for more than 24 hours. But even then, this calculation, I think, would not necessarily work. But depending on your interviewer, it's not necessarily about getting like the most precise code working. What we could have done instead is also saved the day that they were parked and saved the exact date time. And then it would be pretty easy to calculate the exact number of hours that they were here. But I think that kind of takes away from the design. Then we get too far into like implementation details. That's not necessarily what it's about. But I would definitely encourage you to maybe think of an alternative payment system that we could do. Maybe we're charging based on number of days. Maybe we're charging based on something else. Maybe we would also want to charge based on the number of parking spots that they are occupying. It's definitely worth discussing that, and it's definitely worth thinking about that as you're studying and trying to come up with different designs and trade-offs as well. To actually use this, it's going to be a bit of work because we have to instantiate a bunch of classes. We have to instantiate a parking garage, which will have 3 floors and 2 spots for every single floor. We'll have a parking system, which we will pass in the parking garage into, and we'll say the hourly rate is maybe $5 or 5 pesos or something else. We'll have 3 drivers, each with a different vehicle. Driver 1 will have an ID of 1 with a car. Second driver will have a limo. Third driver will have a semi-truck. We'll park each of these 3. The first 2 will return true because we do have enough space for them. We can't park a semi-truck because remember, each floor only has 2 vehicles. So we're not successfully able to park a semi-truck no matter how many floors we have because each one only has 2 available spots. Then when we remove the first 2 vehicles, they return true. We're able to remove them and charge the drivers. But the third one, we can't remove it because we never added it in the first place. So this is one high-level approach for implementing a parking lot. We could definitely have gone deeper into the payment system. I encourage you to think of possibilities where you can extend this design, whether it's extending the vehicles, extending the parking garage itself, or extending the payment system and adding additional details to drivers.